my name is Derek from Tomcat Gas Training and welcome to this video all about this stuff. So let's stop messing around waffling and let's get on and find out exactly what this stuff is, what it does, and are there any other alternatives to this stuff. So as usual, let's get on with it. So what is this stuff then? Well, this little spools are what as gas engineers and plumbers call PTFE. Electricians like to call it plumber's tape for everything. But what its proper name is polytetrafluoroethylene. So that's what the PTFE stands for if you didn't know. So it was actually invented by Dr. Roy Plunkett of DuPont Chemists on the 6th of April 1938. And it was actually a mistake, like a lot of things are when these chemists are trying to invent things. And he was actually trying to invent a new liquid coolant for air conditioning, I think. And he came up with PTFE. He saw it was forming on the side of a flask or something. So that's where it came from. It was invented in America and it is a trade name of Teflon in America. So the American gas engineers and plumbers call it Teflon tape. And it gets a bit confusing in the UK because engineers think there's two different tapes, PTFE tape and Teflon. There isn't. They're exactly the same and you can't actually buy Teflon tape now. But it is still a trade name held by DuPont chemists. So this PTFE came to the UK in 1962. So we invented in 38 and came to us in 62. They had everything from us, the Yanks, don't they? But did you know Gore-Tex, which was invented by Bob Gore, is PTFE? Because of its heating and stretching ability. So that's what your Gore-Tex jackets are made of. They're made of PTFE. It has a melting point of around 327 degrees centigrade. And we've got two different types. So the first type, this one, is your standard plumbing PTFE. And this yellow spool is your gas PTFE. So let's have a look at the gas PTFE first. So it is 12 millimeters wide. So if I open it up, you can see it's 12 millimeters wide and it's actually 0.2 millimeters thick. So it is quite thick. And it's to BSEN 751 Part 3, 1997. And it's only for threads on gas up to 2 inch. Anything after 2 inch, we're going to look at other kinds of jointing compounds later. So our standard plumbing PTFE is again 12 millimeters wide. So you can see it's the same width, but it's less than half the thickness. So it's 0.075 millimeters thick. So you can see it's a lot thinner. And again, it's to BS 751, but parts 1 and 2 rather than parts 3, and it's still 1997. So they are our two types of PTFE tape we use in plumbing and gas. So that's the introduction to them and what they are and what it is. So let's actually have a look and see how you would put this onto our pipe. Come on then, let's get on with it. So the first tape we're going to be using is the standard plumbing tape. So this is the thinner stuff. Now, the hole in the middle should be perfect for your thumb to go through. My thumb is a little bit too fat to go in there, so I have to kind of just balance it on the end. Now, when we get the tail of the PTFE, the way you're going to put it in, so the tail goes to the back. Now, I'm naturally left-handed, but I found it pretty quickly in my plumbing career that if you can't put PTFE on with your right hand, you're going to struggle. Now then, so it goes to the back and your right thumb goes in. Now this is the pipe we're going to be using and we'll actually start at the back of the thread. So if I pick it up, we now wrap the PTFE and use your other thumb to go around, and you can see I'm stretching the PTFE, and once it gets on top of the other PTFE, you can see it sticks, and I'm doing a 50% overlap till I get to the end, and I'm actually winding it clockwise around the piece of 3/4 pipe. So now going back towards the thread, and when I get back to the end of the thread again, I can go back to the front. Now a lot of gas engineers and plumbers will tell you you need between 10 and 14 wraps to make it watertight, and you're just working your way around, and you can see it snaps quite easily and it sticks to each other. So if I get the socket and screw the socket onto the thread, what it does is it lubricates the thread to start off with and makes it watertight by going inside the thread itself. So you can see inside the PTFE tape has not come off, and it's gone inside and not started to bunch up. So I can now put that in the vise and tighten it up. So I've now got my big foot and my Stilsons, and I can now tighten up the socket. So you can see as I'm tightening down, the PTFE is staying where it is and not bunching up on the end. So that's tight enough. So if I get rid of this loose PTFE, you can see that's made a nice joint. Now let's try it and see what the joint looks like when we put the PTFE the wrong way round. So the first thing we'll try, and I'll show you, is using this spool the wrong way round. So you can see it's at the front instead of at the back, and I will start at the back of the thread, and as you can see straight away, as I try to wrap it around instead of tightening, it's just getting longer and longer. So that's the first mistake a lot of people do, is by putting the tail the wrong way. So instead of being at the front, it has to be at the back, that way. So that's the first mistake a lot do, and you can see it just winds off. Now let's try it the right way, but instead of going clockwise, I'm going to go start at the front. So I'm going to go anti-clockwise, the opposite way. So I'm holding the spool the right way, but winding the PTFE the wrong way. Okay, let's bring our socket in again and screw it up, see what happens this time. Well, you can see straight away it's bunching it up and pushing it off. If you have a look in the on the inside now. You can actually see it on the inside there. Let's tighten it up again with the Stilsons. So you can see this time it's actually pushing the PTFE off instead of tying into it. You can see that quite clearly now. And you can see the actual pipe has gone on a lot further than it did before. And you can see it's pretty much took all the PTFE off. So let's take the socket off and find out exactly what's happened inside. And you can see it's a lot easier to get off now. And it's actually not left any PTFE inside. And there's actually not a lot left on the end there neither. So that would potentially leak. Now you could get away with that. It could have actually sealed for a little while. So just make sure you put the PTFE on the right way around. Otherwise, you're not going to make a waterproof seal. So let's have a look at this gas PTFE. So you can tell the difference because one's a white spool and one's a yellow one. But the PTFE is still the same colour. And like I said before at the beginning, this is just over twice as thick. Now, I know I've said that this is slightly thicker than the normal PTFE, but they say this is unsintered PTFE. So that means it hasn't been heat treated. Okay, and what they say is, or the only things I can find is, they say this, because it's thinner, can stretch more, so then it can become brittle and then it can be affected by the gas. That's the only difference I can see between the two. So because this one is thicker and it's unsintered PTFE, it can be used on gas. Now we start at the back of the thread like we're supposed to, and again we do a 50% overlap, but we only do one wrap this time. So that, you can see it's tougher to rip. That is how we're going to do it. Now, I can't find any difference between the gas PTFE and the normal PTFE in the formula. It's just the gas PTFE is twice as thick. That's the only difference. There are no chemical differences between the two. So why we have to use that one and only on gas and not that one, but do twice as much wraps on that one, is beyond me. But you must use the gas PTFE on gas, because that's what the British standards and the regulations say we need to. So let's tighten this back on and see what happens with this one. It does actually feel a lot smoother when you're putting it on, and it does tighten up quite a lot of the way because it's not as much on. So you can see this time the PTFE, because I put it on the right way round, is not spinning around like it was on the last one. It's staying where it is. So that's the nice joint it's made. got a bit of PTFE in the end. So again, you can't see any PTFE sticking out at the end, which is good. It's not going to restrict anything. And you can see it's made a nice tight joint. So let's undo it and see what's happened there. So you can see again it's put PTFE into the thread. So we know that would work. It's put quite a bit into the thread. So that's the gas PTFE. Now, one of the other things you can use your PTFE for is putting around old olives. So just get your PTFE and then just wrap it around the olive a couple of times. And what that will do is it will bulk out your olive, so when you come to put it back on your fitting and tighten it up, it will make your olive watertight again. But one of the things you don't do is put PTFE on here. There's no need for it. It goes on the olive. So when you're using a water fitting, you can do it like that. But again, if you're doing your gas fit olives, then you can either put gas paste on, which I always do. Never put PTFE on it on gas, but you could do. Remember, it's just one wrap over the olive. Okay, so that's how you can remake your olive waterproof by using PTFE. Now, let me just show you a little trick with PTFE you can do if your connection is right close to the wall and you can't do anything about it. You haven't got any paste, you're going to be connecting plastic pipe to this, so you can't use some paste, so you've got to use PTFE. So get yourself a pencil, okay, and the PTFE. Now this is where being left-handed comes in. Let me just find the end properly. Okay, so if I hold the pencil in my right hand and put the PTFE on the end of the pencil with my left hand, you can see I'm going around that way. If I add it the other way and add it in my pencil in my left hand and the PTFE in my right hand, then I would be going the opposite way to we normally do it. Okay, and that's important. So you just wrap that around the pencil till you think you've got enough to fill the thread, and then you take it off, and then we've got the thread here. We just get ourselves our tail back again, put it onto the thread and wrap it around using the pencil. It's as simple as that. And that's how you put PTFE onto a thread when it's up against a wall and you can't get the spool in. I've seen guys break the sides of the spool off and all sorts trying to get it in. You know always got a pencil, do you? So take your pencil out and use your pencil. Little tip for you. So that's a look at these two spools of PTFE. Let's have a look at the alternatives we can get out there. So basically what we've got here are a couple of pastes, we've got a bit of string, and we've got some liquid. So let's have a closer look at these alternatives and find out what they're all about. Now let's have a look at these four products. So first one we've got is Loctite 55. So this is basically a nylon string coated in something, probably PTFE, but I don't know what it is. And it's incredibly tough. So to cut it, you have to put it around the little cutter at the end like that. And this can be used on gas and potable water. So we'll look at how you put that on in a minute. Now we've got another product from Loctite, which is a Loctite 577, which can also be used on water and gas, and it's a liquid. So you have to undo that lock first, and then this is just a sample one I got from Fex a couple of years ago. It's probably out of date, but there you go. And it's like, there's not much in it, and it's like a yellowy orangey colour. Okay, so that's a liquid. Not sure if that's got PTFE in it or not, but it probably hasn't. Then we've got this Jet Lube V2 Plus, which does have PTFE in it, and it's quite a sticky, horrible kind of paste. Okay, we'll have a look at that again in a bit. And then the last one we've got, which I love using, which is gas paste, which again needs mixing a bit because it's been left over Christmas, but there you go. So we need to mix up that oil in there, and again that's a gas paste. I always carry this stuff with me, okay, and I'm lucky if I've got a bit of samples of these. My son swears by Loctite. We won't have any of this stuff, he'll only carry that stuff. Okay, so let's have a look and see what these do. So if we take the Loctite 55, it's pretty much like PTFE, and you start at the back again, but this time we have to go into the grooves of the thread, and then we have to do a couple of diagonal ones that way and a couple of diagonal ones that way. And then we need to cut off the excess. And that's how you put on Loctite 55. Now if you look on the pack here, it also tells you what size and how many turns you need to do of the wraps going around. And the other good thing about this stuff is it will take pressure straight away, and if you overturn it and you need to turn it back a little bit, you can just crank it back a little bit and it still won't leak. So they're the good things about this Loctite 55. It's good stuff, expensive, but it's good stuff. Now the next one we're going to look at is the Loctite 577, which is a liquid. Now this is just a sample bottle I got from Fex, but the first thing you need to do is snip the end off, because otherwise you'll get the liquid out, and there is a little lock on the end which you have to make sure you pull up. There you go. Now next thing we need to do is 2 threads from the end, we need to do a full circle, and because there's not a lot in this stuff you need to go all the way around. Gently does it without missing any gaps. Okay, so you go all the way around, but you also need to go into the first 2 threads on the female side, and it is quite rare to actually put stuff onto the female side when you're doing plumbing and gas. And then you just put the 2 together and tighten it up, and obviously you use a bit of Stilsons on there, but you should also be able to see that the ring is made all the way around the edge, and that'll cure pretty quickly, and you can use it and put gas and water in there pretty quickly also. So that's your Loctite 577. So you can now see the ring all the way around like I've just said, and we've literally left this now for a minute or so, and we didn't use any Stilsons on it, but I am not the weakest man in the world and I cannot undo that. So let's get the Stilsons. So I've now got my big foot. Let's see if I can do it this way. Nope, still can't do it. So get the Stilsons out. Wow, you actually need to put quite a bit of force on it to get it off. that is still incredibly tight. And you can see that's gone all the way on. So again, expensive stuff, but you don't get many leaks using this stuff, according to my son Tom anyway. Now the next one we're going to use is this Jet Lube V2 Plus, which, like I showed you before, is quite a sticky substance. Now it says to put it onto a clean dry thread, but only on the male end, not the female end. So they do say this has got PTFE in it and some other kind of stuff in it, which they don't really say. But that's all you need to put on. And then we can screw our thread on. And then we need to get a cloth and wipe off our excess. And again, you just knit this up with your Stilsons. But let's leave that for a few seconds and see if it actually does set. But I doubt it, because it is PTFE based. So let's have a look and see if I can undo it in a few minutes. So it's been left the same amount of time now as the Loctite was. So let's see if I can undo it. Yep. So I could undo that quite easily with my hands, and it didn't set. And you can see it's made a seal around the edge. So that's the Jet Lube. Now the last one is the gas jointing compound, which is my favourite one, which I've used for years and years and years, and it's never let me down yet. And you can see I have stirred it up now. So it's just a matter of dipping your little pinky in on a clean dry thread. I'll probably tell you not to do this because you could cut your finger on the thread, but I've always done it this way. A lot of you guys wear gloves, and I've never wore gloves, ever, except when I was playing in goal, that is. And I might as well not bothered then. So fill the thread and then get the socket, and with what's left on my finger I just wipe it in there. Not supposed to do this, but it does get just rid of the excess. And then screw it up. And you can see that's probably gone on the farthest anything has. And then just wipe off the excess with your finger, because you don't want to waste it, because I'm tight. And then just get your rag. So let's leave that again for the same amount of time as the other two and see if we can undo it with my hand. So let's try this last one and see if I can undo it. Yeah, that was probably the easiest one to undo. But it is a non-setting gas paste. So that's our gas paste. And that is the end of this video on polytetrafluoroethylene and other jointing compounds for plumbing and gas. So if you've liked this video, why don't you give me the thumbs up or leave a constructive comment down below. If you've not subscribed to my channel, then please subscribe because it helps. And I'd just like to thank everybody who has subscribed, because we've just passed 8,000 subscribers. So thanks very much, it means a lot. And don't forget to hit that notification bell, because YouTube will tell you when we release videos, mainly Mondays and Wednesdays. All I've got left to say is, thanks for listening, thanks for watching, and I'll catch you on the next one, guys. Cheers!